All right, in this example, we need to name the degree of the polynomial. So what that implies is that the degree implies that we look at these numbers up here, 4, 3, and 6. And the name of the polynomial is the highest of those exponents, which would be 6, because that's the largest. Okay, so we would say that the degree of the polynomial is 6. This is a 6th degree polynomial. Okay, so in this one, we need to, again, name the degree of the polynomial. So we're going to look at 2, 5, 4. This one doesn't have a degree on it. Well, it does, but it's hidden. This one has a 1, and this one has a 3. So which is the highest polynomial? That one. So this is a 5th degree polynomial. There we go. In this example, we need to simplify each polynomial expression. So that means we need to look at, here's my first polynomial, here's my second polynomial, okay? And I need to look at what I'm doing with them. I am adding them together. So that just means that I get to take this one as it is. So I get to take plus 6p minus 8p to the 4th power plus p cubed. And then we're going to just bring this one down. 2p minus 5p cubed minus 5p to the 4th. And then I'm adding a plus 6p and minus 8p to the 4th and a plus p3. So let's find our like terms. Okay, that's the biggest one. We're going to combine like terms right now. So is there another just a p term? And it looks like that's right there. So I'm going to do 2 and the 6. So that's 2 plus 6, which is 8. Keep the p on it. Now we're going to take a look at my p cubed. Is there another p cubed? There certainly is. There's this negative 5p cubed, and there's this plus p cubed. So that's a 1p cubed. So to do that, I do negative 5 plus 1, which is negative 4, and they both had a p cubed, so I'm going to keep that. Now we look at my last term. We're done with that, that, and that. So now we got to look at negative 5p to the 4th minus 8p to the 4th. If I take a look at combining those, I get negative 5 plus a negative 8, which turns out to be negative 5 minus 8, which is negative 13, and they both had p to the 4th. And now we got to write it in standard form. Okay, which is highest exponent to lowest. So between these three, p to the 4th is the highest. So we're going to start with negative 13p to the 4th. My next term is negative 4p cubed, so minus 4p cubed. And then this 8p right here is a positive 8p. In order to have a complete expression, I need to have minus signs in between each of my terms. All right, in this example, again, we need to simplify each polynomial expression. So the nice thing about this one, it has a plus sign in the middle. That plus sign means that I just have a plus 5 plus 2n to the 5th minus n to the 4th. All right, so now I'm going to bring down my other expression, the leading expression. So that's 6n to the 5th minus 6n plus 6n to the 4th minus 2. And now I have a complete expression. So we're going to combine like terms now. We're going to combine like terms. We're going to look at 6n minus 6n to the 5th, and we're going to look for another n to the 5th, and that's plus 2n to the 5th. So that's like saying 6n to the 5th plus 2n to the 5th. Now these aren't exponents, so we don't get to add the exponents. We just get to combine the coefficients of 6 plus 2, which is 8. and then we keep the n to the 5th. My next set of like terms, let's see if we can find one that matches this, negative 6n. So we're going to look just for another n, and looking, and I don't see it. So actually that one stays alone. So then we have minus 6n. Okay, now we're going to look for pairs that match with plus 6n to the 4th. So we're looking at n to the 4th, and here's another n to the 4th right here. All right, so that is like saying 6n to the 4th minus n to the 4th. And what you have to remember is that you can put a 1 right here. So you have 6 minus 1. So you have 6 minus 1, which is 5, and it's a positive 5, n to the 4th. And now we look at our last two numbers, which is negative 2 plus 5. And those are indeed like terms. So we can combine them. Negative 2 plus 5, negative 2 plus 5 is a positive 3. So plus 3. And now we're going to write it in standard form. Okay, in standard form, it's the highest exponent. So that is 8n to the 5th. Then we have our next exponent after 5 is 4. So plus 5n to the 4th. And then what we do not have is we do not have an n to the 3rd, n to the 2nd, but we do have a negative 6n. And then we have this last term, which doesn't have an n, so plus 3. And there's our answer in standard form. All right, so in this example, we need to simplify each expression. So again, we have a polynomial plus another polynomial. But that doesn't mean we just get to add each term. That means we got to look into what the signs tell us to do. So we're going to take care of this plus sign, and we're going to make sure that we don't change anything inside. So plus and a negative gives me a negative 6x squared. Plus and a negative 5 still gives me a negative 5x to the 4th. And a plus and a negative 2 still gives me a negative 2. We're going to bring down our other polynomial, negative 8x to the 4th plus 3x squared plus 7x cubed minus 7 minus the rest, this other polynomial. So now we're going to start with combining like terms. All right, so we're going to look. Here's my first term, negative 8x to the 4th. So let's find another fourth term, or x to the 4th, which is right here. So that is negative 8x to the 4th minus 5x to the 4th. The negative 8 minus 5, that's negative 13x to the 4th. All right, next term in line is 3x squared. Is there another x squared term? Oh, certainly is right there, negative 6x squared. So we're going to take 3x squared, which is a plus 3x squared, minus 6x squared. So 3 minus 6 is negative 3x squared. Now we move on to our next term, which happens to be 7x cubed. And there are no other x cubed terms, so we're just going to leave him be. All right, and now we're going to look at our last number, which is negative 7, which pairs nicely with this negative 2. So that's like saying negative 7 minus 2, which gives me a nice negative 9. Now we're going to put it into standard form. All right, standard form simply means highest exponent first. So highest exponent, we're going to put negative 13x to the 4th. Then we're going to put the next one, which is a 3, so that's plus 7 plus 7x cubed. And then the next one is minus 3x squared, and then minus 9. And then we're done. That is in standard form. All right, so in this example, we need to simplify each polynomial expression. And we got to look. In between my two polynomials, I have a minus sign. And that minus sign is going to greatly affect the second expression. And by that, I mean, this means it's a negative 1 outside. So that means I need to distribute a negative 1 to each piece. So that becomes a negative 5b. Negative times a negative is a plus 5b cubed. And then a negative times a positive is a minus 3b squared. So now that I've applied the negative sign, we're going to move over and we're going to bring everything else down. B squared minus 3b to the fourth plus 4b. All right, and from there, it's just like all the other problems. You combine your like terms. All right, so we're going to start with b squared. Is there another b squared? Yep, right there, minus 3. And I include that sign. So I got b squared minus 3b squared. All right, so that's 1 minus 3, so that's negative 2b squared. And now I'm going to take the minus 3b. Oops, what happened there? And so apparently I have to restart this. All right, so we are going to, in this one, we need to simplify this expression. Difference is this sign right here, and that's kind of a big deal. All right, that means that I need to make that a 1. Put a 1 right there. I need to put a 1 right there once my pen starts cooperating. And that's really saying negative 1. It's actually saying this whole thing plus a negative 1 times all of that inside. So what we're going to do is we're just going to treat that as a negative 1, and we're going to distribute it using the distributive property. Okay, so that means right there, and then distribute, and then distribute. So we have negative 1 times 5, which is negative 5b. Negative 1 times negative 5 is positive 5b cubed. And negative 1 times 3 is negative 3b squared. All right, so next step is to bring down our other polynomial we haven't used, b squared minus 3b to the fourth plus 4b. So we have minus 5b plus 5b cubed minus 3b, all of that stuff right there. And now we're going to move to our combining like terms phase. All right, so we're going to look at b squared. And I see I have a minus 3b squared. So that's saying b squared minus 3b squared. Well, you got to remember there's a 1 in front of that b. So we have 1 minus 3, which is negative 2. Keep the b squared. All right, next step. Take a look at the negative 3 negative 3b to the fourth